in AWS ecosystem. What we should know is that AWS is like Legos. You just connect those Legos to build a full, working, scalable, and secure architecture. So that's a little bit about me. So my name is Gurta Berkalem, and I am an embedded systems engineer, and I work for Smile Open Source. We provide various services to our customers. I work in the IoT and embedded system unit. So my daily job is to provide our clients with software that ships in tiny and smart devices. So everything that goes from the kernel to the user space, and then connecting everything to some cloud providers like AWS. So let's jump to the core of the presentation and see really cool things. So let's first bring everyone on the same page. Let's talk about the most commonly used AWS services. The first one is S3. So S3 is the storage service. It's like your Google Drive with much more advanced functionalities like versioning, objects, lifecycle management. So if you have some multimedia files, for example, that were sent by your devices, or even firmwares that you want your devices to fetch for update, for example, you have to store them on S3. The next one is EC2. It's the virtualization service. It's a PaaS service. So it's up to AWS to provide you with the hardware, and it's up to you to handle the software from the operating system to the application stack layer. Most of the time, we use it for longer running tasks. And then the third one is Lambda. So that's the serverless concept, which really distinguishes clouds from on-premise infrastructure. So the concept is that you write some code in your favorite programming language, like Python or Node.js, and AWS will execute it for you. Yes, they provide you transparently with the underlying operating system and the runtime environment. Just pay attention, Lambda cannot execute for more than 15 minutes. And then we have the RDS, that's the relational database. 6 engines are supported today, as we're gonna see later. We have the DynamoDB, that's a great NoSQL database. It's suited for high volumes, read and write with milliseconds latency. And then you have the VPC. You can customize it, you can create subnets, you can isolate resources. For example, you may isolate EC2 instances running databases from other instances running some backend servers. And then you have the last one, which is the SQS. That's a queue which can hold infinite number of messages temporarily waiting for some customers to consume them or even save them to a database. So you guys can check my article that I wrote a couple of months ago if you want to start with AWS. Well, this is good, but today we're interested in real time. So we're pretty much interested in 3 different services which are involved in real time, which are the IoT core, the Kinesis, and Elasticsearch. So let's jump right to the core of the presentation. So let's start with IoT core. So IoT Core is the entry point for your devices to AWS. It's like the gateway, if you want. So IoT Core is shown on the image on the right, but we can simplify its sub-services with the diagram on the left. So IoT Core can be broken into 3 different services. The first one is the device management, where you can monitor, you can command, you can control, you can view statistics for one, multiple, or even all your devices if you want. You can group them by types or even groups. And then you have the OTA capabilities, which are used to update your devices. You have security as well, which is built in with certificates and policies. By the way, policies set access permissions. For example, you may have a policy which can state that some devices have only the right to access IoT Core, but not S3, for example. You can even go further with advanced security features for further auditing. All this is supported by IoT Core. And then the last subservice is the routing functionality called the IoT rule. Why we need this is that because when IoT Core catches your messages coming from your devices, we use the IoT rules to route those messages to other AWS services for further processing or maybe even storage. Let's have a simple example. We should keep in mind that IoT Core concepts that IoT Core accepts only connections using MQTT or HTTP over a secure connection. And your devices should always know your endpoint because it's necessary to send to know where to send the data. The endpoint is always fixed for every AWS account. So in this example, we're going to publish on a particular topic called data car 0001 information. And then we're going to use the routing functionality in IoT Core to route the message to some Lambda function. And the Lambda function is going to check the speed of the vehicle if it is beyond 100 kilometers. In this case, it's going to trigger a service called SNS, which is used to dispatch notifications, in this case, an email notification to the end user. Of course, you may use this architecture for real-time notifications, but you have to change it a little bit because in this case, it can only handle few messages. But if you want it to be more scalable, you have to add at least an SQSQ to have something more scalable. So let's move to the next slide. So in practice, AWS provides ready-to-use SDKs for that you can use in your devices for various programming languages, and that's an example in Python. So you start by importing your SDK, you configure your MQTT client, you generate the payload, and then you send everything to AWS. And by the way, AWS supports only a quality of service 0 and 1 for MQTT. Yeah, so let's see a small demo, quick demo. So here I'm in my email account. I'm going to send some data to AWS, and if the speed I'm generating is over than 100 kilometers, I'm going to receive a notification. So I'm going to start the Python script. All right. For a couple of messages. So now I can write this. So maybe now I can, yeah, cool. So I have 1, 2, 3 speed violations, which are over 100 kilometers. That's why I have 3 different notifications. You see, it's real time. So I have the device name, I have the speed, and the timestamp. Of course, you can customize the format if you want. That's great for real-time alerting, for example. So let's come back to the presentation now. Okay, great. So let's move to Kinesis. That's another interesting service. So if you want to ingest a lot, I mean, a really lot of IoT data efficiently and quickly and hold them temporarily before being processed or even saved to some database, then you can use the Kinesis. So Kinesis comes in 4 different flavors. For real-time purposes, we're going to focus on the first 3 for this presentation. So let's have more insight into each one of them. We start with the data stream. So this is like a big pipeline, but it's not fully managed, and you need to make some configuration when you need more scaling above certain threshold. But something we should know about data streams is that it divides the pipeline into shards. And the more shards you add, the more read and writes you'll get. For example, one application for shards is that you may have one shard for registered users and another shard handling unregistered users. And you're going to process the shard for registered users more quickly is that you may use shards for different device categories. For example, you may have a shard for motorcycles and another shard for cars, for example. Okay, great. Let's move to the fire hose. It's exactly like the previous one, like the data stream, but fire hose is fully managed. You don't have to care about the shards. It scales automatically depending on your needs. It gives you even the possibility to add data and enrich the messages that you receive by calling Lambda functions before any consumer comes and consume the data. One drawback of Firehose is that it has a limited set of consumers. It has a predefined set, and one of them is Elasticsearch. And this is great if you want to do some real-time tracking. Okay, great. The last subservice in Kinesis is called the video stream, and that's great if you want to send your video streams coming from your devices to AWS, and then your customers can just come and use your web application or mobile application to visualize the video stream in almost real time. Okay, great. So once the data is in AWS, how to store it? That's the next question. So the first method which comes in mind is to store the data in SQL. And in AWS, we have a fully managed SQL service called the RDS. 6 engines are supported by now. You can configure read replica for all of them to avoid throttling in primary database. And maybe now some of you are going to ask, hey, but if I have some databases in my on-premise infrastructure, how to move to the cloud? In this case, AWS makes it really, really simple, as it provides full migration service. So you can copy your data from on-premise to AWS, either in homogeneous or heterogeneous way. And that's pretty cool. So after SQL, we have NoSQL. So DynamoDB is a NoSQL database. It offers milliseconds latency at any scale. You can store your data as key value or document objects, or even both. You can even set some TTL value on your data. This is great if you want to do some session tracking. And if you want to reduce even further the latency of DynamoDB, you can enable something called the DAX extension. So you can have up to microsecond latency, and this is great for high volume traffic. So the next one is TimeStream. So as the name, and this is another fully managed service. So as the name implies, it is TimeStream. It is time series oriented database. So you can interact with it using SQL statements like the one which is shown on the screen. You can even organize your data using something called dimensions to query them really fast. So we have other storage services like S3, for example, that we have talked about in the introduction. And then we have the EBS, which is the hard drive that you attach to an EC2 instance when you create it. And then we have the EFS. EFS is a shared file system. So what about Elasticsearch? So everything, so all the previous storage mediums that we have just seen, they are very good. They are great for long persistent persistent storage. But writing and reading from them can be really, really slow, which is not always suited for real-time tracking. So that's why we can use Elasticsearch along with the previous methods, along with the previous storage methods, of course. Why? Because reading and writing from Elasticsearch is really, really fast. And the great thing is that it's fully managed. and it ships with Kibana as well for visualization. So how does it work? You just create an Elasticsearch domain, you fill your indices, and you can start right away reading and displaying from them. And talking about display, so how do we display data on AWS? That's a good question. The first solution is you may use something like QuickSight to get more insights into your data. You can create dashboards and visualize your data using graphs and tables. So this is good if you want to have a quick insight into your data. And then if you use Elasticsearch, you can use Kibana, for example, to build your dashboards and access your indices. Then you can use maps, tables, graphs to display your data. And if both QuickSight or Kibana are not suited for your needs, you can create a custom web applications. So you will store the front end of your web application in S3 and the backend in EC2 instances. This is really scalable. I mean, I did it multiple times and it works really, really great. So let's summarize everything. Let's put everything together. Sorry. So for real-time tracking, you can send your data to IoT Core, which then will route them to Kinesis, which writes them to both S3 and Elasticsearch. S3 will retain all the data. It is made for this purpose. And Elasticsearch will retain only the recent data. You can use, for example, a delete policy to keep only the most recent data. For example, in our case, we're only interested in the last position of the vehicle. You may have noticed something in this architecture. I have used Kinesis data stream and Kinesis Firehose both together. I have used this combination together. This is used to reduce costs. It's going to cost much more if I have used Kinesis Firehose alone. So if you want to check, if you want to compute the cost of your architecture, you may start by using the AWS calculator, which is which gives you a rough idea about the costs. So why not to see this in practice? Yeah. So here I'm inside IoT Core. So that's the entry point for my data, and we can see that I have created a rule. And this rule is called the car tracking, and it's actually listening on this topic. So when a device writes into this topic, then this rule is going to be triggered, and then this rule will send the data into Kinesis Firehose. So let's see it. Let's see it with more. Let's have more insight into it. So I have my Firehose, which is called Firehose tracking, and it writes to both S3 and Elasticsearch at the same time. You can see that you can enable compression on S3, and you can even enable encryption if you want. And for Elasticsearch, you can set the index, you can set the rotation index. Maybe it's weekly, maybe it's monthly. It's up to you. And then the Firehose writes to Elasticsearch. That's the Elasticsearch endpoint, and the endpoint for Kibana in order to visualize your data. And this is exactly what I have in this tab. And by the way, they are going to upgrade to a Maps plugin, which gives more flexibility. You can have layers. You can have better keys for your map, and this is really great. All right, what time is it? We're perfect in time, I think. Yeah, good. So let's come back to the presentation. Here we come to the conclusion. So AWS has all the required services if you want to do some real time, and usually IoT Core is the entry point for messages coming from your devices to AWS, and AWS offers a lot of encryption. I mean, encryption at rest, encryption in transit. For every level that your messages actually travel. And by the way, it's always good to try different architectures for the same purpose. When you build something on AWS, this is good because it allows you to compare between performance and costs. And the last thing I just want to say is that always use something like CloudFormation. When you're dealing with AWS, this is used to automate your architecture deployment. It allows you to easily manage your architecture in the future using only JSON or YAML file, and this works on the fly. Well, here are a couple of links for further reading. I've written the first one, I think 1 year ago, where I have presented how to actually, how a device running Contiki-ng, which is an operating system in the embedded world, can actually send data to AWS. Well, I think we came to the end of this presentation. I hope you have enjoyed it. Maybe we have a few minutes for questions. You can ask in French, in English, please feel free to ask. So maybe I can disable the sharing now. Yeah. Perfect.